So after that, in previous class we have done the nitrogen, its chemical reaction and uses and all that we have completed. So now we are going to study the three main compounds, that main compound of nitrogen. Out of that, and I have explained you that -3, 0 and +3, these are the important oxidation state. Out of that, 0 we have done for nitrogen. Now ammonia, and then nitric acid we will do +5 state. So ammonia, the formula is NH3, and we know that the oxidation state is -3. Okay, so it can be prepared by Hebus process we have done yesterday, and 2 + 3H2 change into 2NH3 at low temperature, high pressure, and in presence of catalyst. And this is the way, this is the on which we can prepare that we can prepare the ammonia on the large scale. This is the main process. Now the next thing is, it can also be prepared by nitrogenous decay of organic material. Nitrogenous decay, that means excretory substance. So we know that human are ureotelic. Okay, so that urea is a excretory product. So here it is, this is the formula of urea. When this urea reacts with water, it gives ammonium carbonate, which on further decompose, and it gives ammonia and carbon dioxide. Got it? So urea on water hydrolysis, and that concept, let's follow that concept. I have told you that oxidation number won't change if it is hydrolyzed. Yes, you can check throughout this. It is -3, -3, -3 over here. No oxidation change in any case. Got it? So this is the thing, that if when urea reacts with water, it gives ammonium carbonate, which automatically decompose in ammonia and carbon dioxide. And that is the reason of a question that it always comes in our mind, that why public urinal smell foul? Yes, why public urinal smell foul? So this is the same thing. We know that human excretory substance, that is urea. So we can write that excretory product of, let me write it with a blue pen, excretory product of human, that means urea. Yes. So when this urea, this is the formula NH2CO NH2, urea, it reacts with the water, and less amount of water. If we are not flushing it properly, we are not giving the water properly over there, so less amount of water, it will convert into this final product I'm writing, NH3 and carbon dioxide. This carbon dioxide as a gas, it will come out, and this ammonia gives the foul smell. This is the reason that the public urinal smell foul if there is not proper flushing, what we say, availability and all that. So it smells like that. Okay. Now next properties, let's do some properties of this ammonia. So what happens when ammonia reacts with water? Everyone knows that if it is water, that means on hydrolysis, this the oxidation number is not going to change. So let me write the reaction. This is ammonia NH3 plus water. We have I think you remember that compound. Let me open this. Okay, so here it is. See, NH3 is minus state. The oxidation number shouldn't be changed. Yes, that is the concept. Now check this. This one, these are the compounds. Okay, so you can see that -3. There are the three possible compound which can show -3 state. So ammonia is itself, it is there. Nitrite cannot form. Why? Because nitrite forms only with the metal, and here it is no metal. So what is the left product? That is ammonium. So this will form ammonium. Either you make it like NH4 plus and OH minus, or you can write NH4OH. So both are correct. Got it? So then same, you can see that the oxidation number is not going to change. Yes. Now the next reaction, what happens when ammonia reacts with zinc sulfate solution? So here also it comes like zinc sulfate solution. That means indirectly the water is there, isn't it? So let me write this ZnSO4 plus ammonia if I am writing water, and plus ammonia if right. So what will be the product? Again, the oxidation number shouldn't change. Oxidation number will not change. Got it? So here the two things are like what compound it can form. It can form nitrite. Nitrogen has two different compounds. either one is ammonium, another is nitrite. So nitrite it can form because metal is there, isn't it? So it can form metal nitrite. So like, let me make this. So if you are making this Zn and 3n2, metal nitride it can form. So what next? Zinc is used, nitrogen is used, so H and SO4 is there. So this is H2SO4 you can make. Okay, so but still, since it is acid, it will give the water, and finally what happens, this nitrites will convert into ammonia, and this zinc will convert into ZnOH whole twice. So either you write this or you write this, both are correct, but the appropriate one is this. Got it? Ammonia and zinc hydroxide, you can see that there is no oxidation number change. Yes, if you are making if you are writing this product directly, so along with this H2SO4 also you will write. Okay, this zinc nitride will give you like this formula, this compound, and H2SO4 will remain like that. Got it? Okay, let's try for the next question, next reaction. No need to learn the equation, just the concept. Use the concept. You will be able to at least 60 to 70% equation you will do by your own. There is no like any doubt over there. Only few reactions that we have to learn, and then since the things are there to learn, so that's why you have to learn over there. Okay, so let's this, and again, whenever this is we say it is ammonia with FeCl3 solution, because solid के साथ कभी भी ये react नहीं करते ये सब. So if solution, if you take, so this is, let me take this equation, this is FeCl3 plus water plus ammonia. So what next? Again there will be no oxidation reaction, that this is hydrolysis, like hydrolysis. So we can say that the oxidation number won't change. Got it? So all this concept, oxidation number will not change. So now Fe, again you can make this nitrite, and finally it will give you like this. Got it? So I can write directly FeOH whole thrice plus what next? This is ammonia, N is left, hydrogen and Cl is left. So make this compound NH4Cl. Isn't it? Or if you make it like this, Fe3 and 2 plus SCl plus like this ammonia, what we say, nitrogen is done. Yeah, this you can make. Okay, along with this water will be also there, water, because it is this water will remain in that case. Okay, so if you are making this compound, you have to make the water over there, or if you are writing this, there is no problem. So both are correct. Got it? But the most appropriate is, as I told you, this. Okay, now the next reaction, think of it, and I hope you will do. So what happens when ammonia solution reacts with calcium chloride? So let me write this ammonia solution, that means NH3 plus water. Ammonia solution can also be written as NH4OH. Got it here? So this is, and plus calcium chloride, CaCl2. What will form? Either you will make that calcium nitride, which will finally give like this. So we can write directly, yes, CaOH whole twice, and since there is no oxidation number change, so it will be NH4Cl. I hope it is clear. What else you can make? You can make this Ca3N2 plus HCl plus H2O. Yes, this will finally give this, so you can write this product direct. Now the same thing again, tell me ammonia solution with sodium sulfate. Ammonia solution is NH3 plus water, and sodium sulfate is Na2SO4. So tell me the product fast. Yes, finally last we can make. Yes, so what will be the formula? This is ammonium sulfate we can make. Yes, and NaOH whole twice, NaOH and ammonium sulfate you can make. Yes, or if you want to make the nitrite, what next? NaN3 plus water will be there, and this will convert into H2SO4. The correct one is this one. Clear, bache? Any doubt? Okay, now this is to learn. ये point आपको learn करना है because यहाँ concept नहीं काम करता, यहाँ पे learning है. See, some d orbital elements like copper and silver. This is only two elements, copper and silver. When reacts with ammonia, it gives a complex. D orbital is here, zinc also. But when it reacts, this gives the compound, normal compound. But when this copper and silver reacts, they form a complex compound. And how to learn this complex? Once you will do this D block element, when you will do, it will be clear over there. So here I am giving you a small idea for this. See, copper, so copper 2 sulfate, we are taking the solution, copper 2 solution, sulfate or chloride, whatever, nitrate, whatever, the copper 2 solution, then ammonia. So what will happen? This will form a complex. Whenever we write a complex, it starts with like this. It's in the box, and the after the box, we have to write the metal. Okay, and the ammonia act as a ligand. What is this now? Ligand, you will understand in the coordination chemistry. So for till now, you just learn this point. Ammonia, okay, and here we have to write some number. This number is always like maximum case, only 2-3 cases are there. Maximum cases, always this number is double of this oxidation number. What is the oxidation number of copper over here? 2. So that means it must be 4 over here. Got it? Like this. And this, so to make this, it will the charge over there like this. Suppose that instead of this, if it is given CuSO4 plus ammonia, what you will write? What you will write as a product? This will be Cu, the big bracket, Cu ammonia is going to going inside NH3. What number? Obviously 4, because I told you oxidation number. And instead of this plus 2, what now? Now we have an anion. So this anion we will write over here. We will not write the charge over there. Got it, dear? If it is chlorine, so this instead of this sulfate, the Cl2 will be there. Got it? So it is like this. Now let's do for another equation, that is Ag. Ag is always carrying the +1 charge, NH3. Can you think what will be the compound? Think, just tell me fast. Yes, very good. This is Ag, NH3 whole twice, because oxidation number is 1, so obviously it will be 2. And here we will write +1. Or instead of this Ag ki jagah pe, suppose that AgNO3 I am giving you. AgNO3 plus ammonia. What will be the product now? The product will be Ag, NH3, and NH3 will be 2, and this NO3 will come over here. So right now, till now we have done at least I think 10-12 equations we have done. 10-12 se more than 10-12. So out of that, only one reaction you have to learn, isn't it? ये सिर्फ एक reaction आपको भी learn करना है. Got it? Now we are going to start the third compound and the most important compound, and here lots of reactions are also there. So that is +5 state nitric acid. Okay, +5 state nitric acid. So nitrogen can form different oxo acid. Oxo acid, that means it is acid because it is losing H plus. Yes, and along with this oxygen is also there. So all the acid which gives H plus, but that H plus which is attached with the oxygen, are you getting it? That is called oxo acid, like H2SO4. So it will lose the H plus, that H plus only which is attached with the oxygen. So that is called oxo acid. Nitric acid, hydrochloric acid. Is it an like oxo acid? No. Even class 10th only you have learned about this. It is not an oxo acid. HCl is not an oxo acid. Okay. Oxo acids are such acid which liberates, which gives H plus ion, but that hydrogen must be attached with the oxygen. Okay. So it forms different oxo acid, and that is the H2N2O2. H2N2O2, it is hyponitrous acid. What is the oxidation number over here? This is, tell me fast, it is +1. H2N2O2 -4 +2, so it will be +2, and for 2 it is +2, so for 1 it is +1, isn't it? Now HNO2, this is +3, and HNO3, this is +5. Out of this one is the most stable acid. Clear, bache? Okay. One more thing I just want to tell you, all the non-metals, this is important point, you can write important, you can mark it as important. All non-metal shows its maximum oxidation state, shows its maximum oxidation state in its oxo acid. Okay, जितने भी नॉन मेटल्स होते हैं वो अपने, इवन मेटल ऑल्सो वी कैन से, ठीक है, इट मैक्सिमम ऑक्सीडेशन स्टेट इन इट्स ऑक्सो एसिड ओनली, नो अदर कंपाउंड. तो मतलब इफ यू वांट टू चेक द मैक्सिमम ऑक्सीडेशन स्टेट, ऑक्सीजन मस्ट बी देयर, हाइड्रोजन मस्ट बी देयर. गॉट इट. बाकी मेटल को लेके वी कैन मेक द कंपाउंड. चलिए लेट्स डू मेटल और नॉन मेटल को लेकर. Let's do some reactions for this preparation. How to prepare the nitric acid. So to prepare the nitric acid on we can do the reaction sodium nitrate and sulfuric acid. So sodium nitrate, what is the formula of sodium nitrate? NaNO3, isn't it? Plus sulfuric acid. So just if it is acid, here acid is there. If acid is there, that means indirectly the water is there, and water is there, that means no what? No oxidation change. Got it? So what we will do, we'll make the compounds. This is HNO3, the simply double displacement we can say, HNO3 plus Na2SO4. Yes, no oxidation change because acid is there, and acid means indirectly water is there. Now if I will use this instead of the sodium nitrate, if I will use sodium nitrite, this is NO2, this is sodium nitrite. Okay, so tell me what will happen if it reacts with H2SO4. What type of, which acid it will form? It will form nitrous acid, HNO2 plus Na2SO4. Got it? This is nitric acid, and here it is nitrous acid. Any problem in this? Now this was the reaction, important reaction, but now it is not. Earlier this was asked that write the equation or write the preparation of nitric acid by Oswald method. So you were supposed to write all the reactions, but now it is not like that. Okay, let's but still let's do this equation. So what is the reaction in this case? First, this ammonia reacts with oxygen to give nitrogen oxide along with the water. Okay, this is the reaction. Again, you just check oxidation reduction and redox. What is, so here it is -3, it is in the least, and here it is in 0, yani ki in between. So it has chance to oxidize as well as reduce, but this, since it is in -3 least, so obviously it will only and only oxidize. Got it? It will only oxidize. This can reduce as well as oxidize. So now if this one is oxidizing, so obviously this has to be reduced. So oxygen reduce होके एक ही state होता है, that is -2. That means -2 we can, and here -3. So it can form various we can say this is the equation, various acid it can form, oxide it can form, but the basic oxide jo hota, this is NO, the first one. Now I want to tell you, why not nitrous oxide? This is the first oxide na. Nitrous oxide, there is a special method for preparation this. So in general we cannot make this equation. मतलब like कभी भी हम कोई reaction लिख रहे हैं तो ऐसा नहीं कि oxidize करना है तो we can write this N2O. No, we will not write. We can write this, we can go for this, but we will not write this. इसके लिए there is a special method to form. Okay, that we will do afterwards. So now NO will form. Now if I want to balance it, so this is 3 and this is 2 over here, so let me do this. This is 4 over here, 6, and now 6 and 4, 10. So this is 5O2. Got it? This is the balancing. Now this nitrogen oxide which formed, now this nitrogen oxide will react with the oxygen and will convert into nitrogen dioxide. Okay, so this is to balance it, to make it 2 over here, 2 over here. This is done. Now this nitrogen oxide, nitrogen dioxide will react with water and will form what? Ab see, यहाँ पे what is the oxidation state over here? This is +4. That means in between, isn't it? Let me open again. This is, here it is NO2, this is NO2. Yes, in between. So what it can form? This is, the higher one is this, oxidized product, ये for sure ये बनेगा. And since water, hydrogen is there, so we have to use this hydrogen. So what we will write? HNO3. So we will make HNO3, one product for बन गया. Now what will be the reduced product? Reduced product can be, इसके नीचे का reduced product. It can be this, it can be this. But N2O3, I told you, this oxide is again not so common. So we will make this NO. So वापस this NO we will give. And this NO will again react with this oxygen to give NO2, and this reaction will go in process until or unless all the NO will be consumed to convert it into nitric acid. So here it is the +2 state. So what we have seen, there is the oxidation as well as reduction. Which type of reaction it is? The last step is disproportionation reaction. Got it? So this is the reaction in the Oswald method. Oswald method is the method to prepare nitric acid on the large scale. Clear? Okay, now whatever I'm going to start, this is very important part of this topic. Or if in 15th group mein, this one is what we say, most important part. Properties of nitric acid. So see, whenever in general, whenever we have done in class 10th, whenever the metal reacts with any acid, it liberates hydrogen gas and metal nitrate will form, isn't it? तो वही सेम चीज़ है, थोड़ा सा हम यहाँ पे उसको we will modify it. So whenever it is general trend, whenever metal reacts with HNO3, it will form. And one thing, if you could remember, I have told you in class 10 that if in this side, reactant side, nitrate is there, so there will be side product NO2, sulfate is there, SO2, carbonate is there, CO2. This is the must product. You can keep in, you can write in short. Okay? If nitrate is this side on the reactant side, NO2 will be the sure product. If sulfate is there on the right side, SO2 is the must product. If carbonate is there on the reactant side, CO2 is the must product. Got it? So if it is nitric, so what will the one product for sure we got? Yes. And another product is also you can find. If acid is there, 2 points I have told you. Okay? Nitrate on the reactant side. Product, it will give you NO2. Yes. Sulfate will give you SO2. And carbonate will give you CO2. Got it? This is the one point. And the another point. If acid is there, acid is in reactant side. Class 11th, if you could remember. Acid is in reactant side. Water will be must product. Got it? In redox chapter we have done this while balancing, isn't it? Yes. So these 2 points again. So this is nitrate over here, NO3 nitrate over there, so that's why NO2, and acid is there, so another product water. Got it? Clear? So now just check what happened. Here metal is in the free state. Okay? So this nitric is here 5, and this has gone to reduce in +4 state. That means reduction occurred. If reduction is there, so for sure oxidation will be there, isn't it? Oxidation will be there. So metal को oxidize करेंगे तो क्या बनेगा? Metal nitrate. That means whatever the state, it will metal nitrate. Let's do general equation. Like if I am doing this FeHNO3, either conc or dilute. There is no problem in this. Conc or dilute. Okay. This will give you. Let me write over here. Conc or dilute. There is no problem in this. It will give you FeNO3 whole twice plus NO2 plus water. Got it? But now exception which you have to learn. What you have to learn? If this reaction is with copper and zinc, if it is with copper and HNO3 conch we are using, with the conch there is no problem, जो बना रहे थे वैसे ही बनेगा. If you are using conch, so this will give you CuNO3 whole twice, yes, plus NO2 plus water, no issue. Similarly, if you are using zinc and HNO3 conch you are using, again there is no problem, the same thing, it will give you ZnNO3 whole twice plus NO2 plus water, yes. But if this is reacting with the dilute, everything will be same, this will be same, there is nothing, no change in this, there is no change in this. The only change is instead of this NO2 it will give you NO. Got it? The only change when it is dilute. Clear? And similarly, if this Zn is reacting with this dilute HNO3, so again no change in this, no change in this, but instead of this NO2 another oxide, and that oxide is N2O will form. Got it? So this is the two specific thing you have to learn out of this. Got it, dear? Any doubt on this? Okay. Thank you, class.